Hey guys, so in this video we will be talking about a interview linked list problem on LeetCode, specifically dealing with finding the intersection node of two linked lists. So as you can see here, we have two linked lists. I'll call them head A and head B. And these two linked lists have an intersection point at this node, since these nodes have the same value, and similarly 4 follows in both instances of the linked list. So our goal is to create a function like so. We'll call it getIntersect, and then pass in two variables, head A, which is this linked list, and head B, which is this linked list. And the goal of passing this definition is to return a node that is the first node that, after iterating through each of these linked lists, will be the same for both linked lists. So in this case, it would be the node that contains the value 2. So in order to implement this function, we have to actually create a separate definition, function definition, that deals with the length, because as you can see, head A and head B are different values in terms of the length, and we have to compare them, each of these nodes, by aligning them up so that in a more picturesque fashion, let me put these down here. We can have it so that this node, this linked list, is matched up with this linked list, so that we can link these nodes to this merged linked list, because 2 and 4 follow both nodes, or both linked lists, head A and head B. So we have to somehow be able to get to this point with this function definition. So let me copy this, and let's start implementing the definition function. So as I mentioned earlier, we need some way to find the length of A and B, so that this linked list, head B, can be two nodes after the first node of head A, so that we can have it aligned up like so. And in order to do this, we have to create a definition that deals with length. So def length, and this will have one parameter, which is L, which is the length, or the linked list, and we will initialize a lowercase l, which is 0, and while L is true, so while the linked list that we are passing into the length definition is true, increment lowercase l, and this, by the way, is equivalent to L plus 1 equals L, and sorry for the similarities between L and 1. So while L is true, L, let me denote it differently. Let me denote it like this: lowercase l increments by 1 every time L is true. And in order to actually increment through a linked list, like so, we have to iterate through. So L will become L.next, will become L.next, ... as we iterate through the linked list, and lowercase l will equal 1, 2, and 3, dot, dot, dot. So lowercase l will increment as l equals l dot next. And finally, we have to return the numerical value that we output from lowercase l, which will be lowercase l. So this is our function definition for length, which we'll be implementing in our getIntersect definition shortly. So how do we actually use the length implementation? Well, I'll show you what we write, and then I'll explain how we do it afterwards, where LA is going to stand for the length of A. So in our example, the length of A is 1, 2, 3, 4, 5 nodes. So lowercase l will be 5, and head B will be 1, 2, 3 nodes. So lowercase l will be 3. So lowercase l of A is going to be 5. So in order to put this in our function, we have to call it like lowercase la equals length, which is our definition that we defined, and in brackets we'll have it head A. Head A, as you can recall, is this linked list that we pass into the definition, and it's more specifically this linked list pattern. So now that we have the length stored inside this variable for node linked list A, we can do the same for linked list B, where length head B equals this value. Okay, so now that we have the lengths, we can finally use them, where if lowercase a is greater than lowercase lb. So specifically we're talking about if, let me erase this, if the length of header A is greater than the length of header B, then we do whatever is inside this if statement. Specifically, we have to make a for loop where for underscore in range, the difference between the length of linked list B, actually linked list A, because linked list A is bigger, minus linked list B, we increment head A. So in other words, if this this linked list is greater in length than this linked list, which is true in this situation, then we will increment head A, which is currently residing on the head node, until we reach the range of LB minus LA, which is in this case 5 minus 3, which is 2. So range of 2 is dealing with 0 and 1. 2 is not included as per the the built-in definition of a range in Python. So we will be moving head A 2 times. So head A will be moving here in iteration 0, and then in iteration 1, head A will be here. So we've effectively made it so that the new head node, technically in quotation marks, the new head node, which is actually this, but we technically made it so that the head node is now this node, which is the value 1. And in doing this, we can finally compare just these nodes, which makes the rest of our code much easier, and I'll show you how. So before we go on, we also have to create the situation where if lowercase b is greater than lowercase a, in other words, if the length of the linked list lb is greater than the length of the linked list la, we have to do something. So I'll create an else statement, and it'll be just like this for loop, where for in underscore range lowercase b minus lowercase a, and then we'll make it head b instead of head a. So head b equals head b dot next. So now that we've formalized the head node for the linked list that has a greater length, we can now go into a while loop that runs while head A and head B are true. In other words, while head A and head B are iterating to actual nodes. So the moment head A or head B reach null, then the while loop will exit. So we have it so that while head A and head B, and within this we'll say if head A is equal, double equal sign because we are comparing, if head A is equal to head B, or sorry, we're not comparing, but we're finding it whether this equality is true. If head A is equal to head B, let me emphasize that this is one word. This is also one word. Then we return head A. Or we could return head B. It doesn't matter since head A and head B are equivalent. So if head A is equal to head B, then we return the node that head A is currently on. So right now, head A and head B are not on the same node. So we have to have it so that head A is going to be on this node and head B is also going to be on this node. When this condition is met, when head A is equal to head B, then we can return this node since they're equivalent. But how do we iterate both of these variables to this node? It's simple. We just do head A equals head A dot next and head B equals head B dot next. Yeah, so now that we have these variables iterating while this is true, we can keep iterating until we get to the point where head A is equal to head B, and in which case we just return head A, and that's basically the gist of the function. And finally, if we never reach a merge point, we return none. So in other words, if these two nodes, if these two linked lists, head A and head B, never merge, then we just return none because there's no node that starts the intersection. And that's pretty much it. We have completed the intersection interview problem. And yeah, let me know if you have any additional questions in the comments. I'm going to link the LeetCode interview problem that we are looking at in the description. And please let me know how your data structure progress is going. And I'd be more than happy to encourage and give any tips and feedback. Thank you so much for watching, and hope to see you in the next video. Peace.